Welcome to this demo for the Mira Security Encrypted Traffic Orchestrator, also known as the ETO. In this short video, I'll be showing you how you can use the ETO to decrypt traffic that's encapsulated within a tunnel. As you can see in this network diagram, I have the ETO and network inline. That means that the ETO will be directly between our test client and the internet. It will actively decrypt SSL connections, even those within a tunnel when a setting is enabled. This is key because in most security appliances, in order to decrypt and inspect the traffic, the tunnel must be terminated, run through the visibility tools, then restarted. However, the ETO is able to detect tunnel headers and skip over them, allowing it to look into the tunnels and decrypt the SSL connections. I will generate test traffic by downloading the iCar test virus. This will simulate a user downloading a malicious file or visiting a malicious website. For the first test, I won't enable decrypt traffic in tunnels. The traffic will pass through it, but since the ETO will be set to not decrypt the traffic, we shouldn't see the test file. It is functionally just a wire in this instance. The traffic does get sent to the app ports, but it is the encrypted traffic. For the second test, I will set the ETO to decrypt traffic in tunnels. This will decrypt all SSL traffic, including that which is in a tunnel, and re-encrypt it before sending it on to the destination. The traffic it sends to our app ports will be decrypted in plain text. If we look at our segment settings, we can see that decrypt traffic in tunnels is disabled. I'll start the Wireshark packet capture for this test, and it'll allow us to see the plain text within the traffic. Now we'll go over to our test client, open our browser, and go to the iCar site to download the test file. Like I mentioned earlier, this will simulate the malicious traffic that a user wouldn't notice, so it's IT's job to notice it. As we can see, the file downloaded. Taking a look at our browser, we can see that the certificate is the original from the site. When I go over to Wireshark, we can see that in fact there isn't anything showing here. This is because the ETO didn't send the traffic to the app ports because all of the traffic was encapsulated in the tunnel. If we go back to the ETO and go to the SSL session logs, it doesn't look like there's anything there either. This is because the ETO isn't parsing through the tunnel traffic, and so doesn't know that there is SSL connections at all. Now we'll tell the ETO to decrypt traffic in tunnels. We'll select our segment, click the checkbox to enable it, click Save, then reactivate it to apply the change. This policy applied to this segment is set to Universal Decrypt. It will decrypt and re-encrypt traffic between the client and server to access the unencrypted plain text, which will be sent to our app ports. Let's go back to our test client. We'll go back to the iCar test file download site, and we can see that the file did in fact download. According to our browser, the ETO is re-encrypting the traffic with its self-signed CA. When we take a look at Wireshark, it appears that the iCar test file is now able to be detected, and we can see that it's all HTTP and TCP traffic rather than TLS. And when we go to our ETO SSL session logs, it's detecting SSL traffic and showing it as being re-signed. As you were able to plainly see, the ETO allowed our traffic within tunnels to be detected. This can be a key feature in any network where tunnels are being utilized. To learn more about key features of the ETO, head on over to the Mira Security channel page where you'll find a wide variety of tutorials and demos. For any more information, please check out mirasecurity.com where you can find more about the ETO as well as a Contact Us button at the top of the page.